Welcome to the R Lab on ridge regression and Lasso and some Bayesian model averaging for prediction. In this lab, we're going to go through and use these different shrinkage methods and model averaging, which does some processes similar to shrinkage, to do some regression methods. And when I say that model averaging does something similar to shrinkage, I should be more specific. Model averaging gives you a set of coefficients, and they're weighted by the probabilities for the models in which those coefficients appear. So they will give us reduced values for the low probability models. So we have to read in our hitters data and prepare it and get rid of some of the NAND. So we're executing the commands that are in the top of our library file first. And now let's come back down to the area where we have the ridge regression and Lasso, and then we've tacked on some model averaging at the end. So we're going to use a GLM net library, and so to use that library we have to split our data into X and Y separate. Now we're going to do ridge regression, read in the library. We're going to create a grid. This is a grid of lambda values that we're going to be searching over to find the best lambda. And so we've created a GLM net ridge regression model, and when we set alpha equals 0, that determines that this is a ridge regression model. We can look at the dimension of the coefficients. We can look at, and so we've got 100 different lambda values, 20 coefficients each. We can look at the lambda value that's for the 50th entry, and we can look at the coefficients, and we can look at the magnitude of the sum of the square of the coefficients. Remember, that's the measurement that we're trying to keep small in ridge regression. We can look at the ridge and the coefficient at 60, and there we have a lower magnitude of our coefficients. Now we can use a ridge regression to do some prediction. So that's our prediction using ridge regression. So what we're going to do now is take a training set and a test set, and then we're going to try to use a ridge regression. We're going to train it on our training set and then apply it to the test set and see how much better it is than the full model or just the intercept. And so we've created our training and test set, and now Y is going to be the Y values for the test set. So that's Y.test that we're executing now. And so now we're going to create a ridge regression model, and we're only going to create it on the training set. So we're going to train it with X train and Y train. And then we're going to use it to predict, and we're predicting now on the test data. And so now we're going to compute the mean of the ridge minus prediction test squared. And so this will give us the mean squared error. So the mean squared error using ridge regression is 101,036. Now, if we looked at just using the intercept, our error would be 193,235. So we're better than just using just the intercept. If we predict, so that's using just the intercept again. If we predict with the full model, and that's what this exact equals t command does, or let's look at it down here, exact equals t. This, we're using the training data, exact equals t says use the full model, and so our evaluation on the full model, or our error on the full model, mean squared error is 114,000. So to review, our mean squared error here using ridge regression is 101,000. The mean squared error using just the intercept is 193,000, and the mean squared error using the full model is 114,000. And now we're going to create we can output some of the coefficients for the ridge regression. So let's set our seed again. And do some cross-validation error. And This is mean squared error as a function of log of lambda, and we find the mean squared error gets best in there, and so we can take a look at the best lambda value is 211. So log of 211 5.35 is where we're getting our best results. So we can use ridge regression and do a prediction at that point, and our mean squared error at the best location is 96,000. And so we can look at our coefficients using Lasso. So this is our best results. So for 96,000 as our mean squared error, that's using ridge regression at the lambda chosen using cross validation. And an important part, just to remind ourselves, that cross validation up here was done only on the training data. Okay, so we created our Lasso model. We can plot the Lasso model, and remember this is L1 norm. We're looking across the horizontal as a function of lambda. No, as a function of the L1 norm of the coefficients, sorry. The vertical axis tells us coefficients, so we can see the coefficients from right to left shrinking down to 0 as you go across, and we are doing Lasso, so at some point these coefficients will tend to actually hit 0. So we're going to use some cross-validation on the training data. That'll help us predict the best lambda value based on cross-validation. And so the mean squared error using the best lambda is about 100,000. And then we can look at the coefficients that corresponded to that model and the coefficients that were not 0. One more method that we've talked about that acts like a shrinkage, that eliminates or reduces some of your regressive variables, is model averaging. And so I've added in, and I used my horrible commenting. Don't ever use this format for commenting. I use it horrible, the standout form of commenting from what's in the library here, the code for our project already. And so we're going to use the BAS library for model averaging. So we're going to create our Bayesian model averaging model on the training data. And now we're going to predict on the test data. And then we can compute our mean squared error. And that prediction is done by taking the coefficients that were determined by taking the average of the coefficients over the models where it's a weighted average based on their probabilities. So look at the mean, and we get 94,000, which is a little lower in mean squared error than the, let's go up, take a moment to go up, the mean squared error that we got from Ridge using the best lambda, which was about 96,000, and better than the Lasso, which was a little over 100,000. So if we go up, here's the mean squared error using model averaging, 94,541. The mean squared error using ridge regression, using the best lambda, measured using cross-validation, is 96,015, and the mean squared error for the Lasso method was 100,000. So we see all three are performing notably better than the full model, with the model averaging giving us the low mean squared error. These three methods, I wouldn't extend that to say model averaging is always better, but it's a good method. It's a good tool to have in your toolbox. Thank you very much.